So your turn to intro this one.
Yeah. So what we're doing this one about RCD protection on
TT. Well,
TT,
mainly TT.
Solar and battery and the complication with TT.
Yeah.
Okay. Ready?
When you are.
Hi everybody, and welcome back to the Renewables Podcast. Hi everybody, welcome back to the Renewables Podcast. So today we are going to talk about RCD protection on inverters, on battery systems, the complications that is when you have a TT earthing system. I'm looking forward to Mark's insight on this because we've both started to come across this problem with some very recent jobs and quotes that we're doing. But firstly, without further ado, how are you doing, Mark?
I'm good, mate. I'm doing very well. For you watching, this will be another week, but this is literally 5 minutes after we just recorded another podcast. Cue a storm flooding the warehouse that Sam's got out there, so he's been busy sweeping up. But I'm ready for this chat. Like Sam said, this is something that is affecting us, and it's actually caught me out, as I mentioned in a couple of episodes ago, not on a TT system, but still caught out by RCD protection with an inverter. So I think this is going to resonate with a lot of other installers, and hopefully I'm not the only stupid one out there.
I wouldn't even class it as being stupid, Matt, because I shared one of your posts, or you tagged me in one of a Solis inverter that you'd been called out to that was tripping an RCD, and I'd put about that, and we literally, I think that same day, had a conversation about a SIG and store battery system that that I was pricing to do, and it was on a TT system and all that. And we'll get into all that, but it's weird how common this starts to become when you really look at it. And conversations that I had on Instagram with 2 or 3 other installers that were kind of suggesting ways around it, but then they hadn't factored in there was a TT earthing system and other things like that. And suddenly I mentioned that we were going to do this podcast, and I said, hopefully it just, even if everyone else knows it, it'll answer the questions for me. But they reiterated that they don't know the answer to it either. And they're doing solar PV and battery storage systems as well. So I think sometimes you don't necessarily know there's a problem until you actually come across that one situation. You might have gotten away with it in the past, by just fitting a 30 milliamp RCD onto something and it not trip, but you start to get to that point where it then starts to trip. It's kind of like, well, where do we turn? And we're going to go into kind of the issues around that and potential solutions around how we get around not putting a 30 milliamp RCD on something that is something that's on a TT earthing system.
Yeah, I guess that's the crux to it all, is the earthing system rather than what the inverters want. And different inverter manufacturers will state different things in terms of their RCD protection that you need for them. And it maybe resonates into the world of heat pumps as well, with the RCDs that they need to install, that manufacturers might be saying have to be in place to comply with those instructions. And on a TT earthing arrangement, they might be facing this with a different piece of equipment. And it kind of all traces back to understanding, I think, the difference between fault protection and additional protection with a TT earthing system, and then how you set your RCDs up once you've understood that. So just speaking about the kind of the fault protection side right from the very beginning with TT, you don't necessarily have to have RCDs to achieve fault protection on a TT system. It says in the regs that you can not have them if you've got a stable and reliable enough earthing system in place for your normal MCBs to operate under fault conditions. Now, that's really unlikely that you'd be able to make that decision. I can think of maybe a few examples where it would be the case if you've got, a massive steel structure which is buried into the ground and it's right next door to the transformer that's also got electrodes right into the ground, and your RA, ZE could be at very, very low numbers, and you could make an engineering decision that, okay, I'm happy that maybe we can use fault protection using normal MCBs. But in most TT systems, we're going to be using RCDs for fault protection. And the way that would be done historically, people of my age will know how these things used to be set up. You would have a 100 milliamp RCD on a domestic system sat up front with old 3036 wire fuse wire boards. This is pre-30 milliamp RCDs. And then they kind of went through this phase of updating some of those for 30 milliamp RCDs and split load boards on your final circuits. And the regs kind of evolved through the 15th and 16th edition to account for that. But that 100 milliamp RCD of the time was providing the fault protection. So if you get a short between a line conductor and earth, you're going to see that operate to give you fault protection within your installation. Additional protection is different. That's for kind of socket outlets, and as the regs have evolved, luminaires now, so that's also included in the regs. Buried cables within a dwelling as well, where you have to provide that additional 30 milliamp protection. So I guess that's kind of trying to set out very roughly the difference between the two. And with fault protection, you can have an RA of 500 ohms and achieve the disconnection time you need with 100 milliamp RCD. So as long as you've got an electrode value under 500 ohms, which you'd hope you would have to comply with other elements of the regs anyway, you can have 100 milliamp RCD up front on the install. And again, we've changed those things because of the way selectivity works with RCDs. So now we have time delayed 100 milliamp RCDs up front. It's a distribution circuit, so we've got longer to clear that fault. And it's how you set all of that up with a solar PV system that we'll get to through the course of our conversation, because there's some other things that we need to consider as well. But that was my understanding of it all. So in basic terms, if you've got your inverter now, your SIG install, for those of you who don't know, they can have a 100 milliamp as the minimum value on that product. If you put a 30 milliamp on, it trips. I know because I've done it. Then that's what you're going to need to have in place. And that complies with BS 7671. It's not a deviation in that application, as long as you pay some attention to the RCD upstream of that, which we'll get to in a minute.
Yeah, no, and this is kind of, we didn't get into this much detail because that's what these conversations are about. You know, we're both dealing with kids and half term and all that, and you're kind of trying to work out how to kind of get an install priced and over the line and everything. And I think as well, even though in previous podcasts I've been branded as a regulation corner or whatever, you know, sort of in that sense, when you're running a business and when you're doing these installs and you're trying to spin all these plates, I think it's sometimes difficult to retain that sort of information. And I think knowing where to find it and having resources like hopefully this will become over the course of this chat is good as like a little memory jogger. Because I'm trying to remember that table, it's like 41.5 or 45.1 something like that, where it shows the maximum RA or ZE readings of that earth rod to achieve a disconnection based on the RCD level. And yeah, I think there's in the electrical industry it can be you can kind of fall into patterns. Certainly when you fit in one type of product or one range of products, you kind of have that print, it's sort of copy and paste pricing structure. Because to be honest, that's certainly on the initial install side of things, it's quite difficult to go into a hugely technical quotation when you haven't even been to site. So I think you can kind of fall into the trap of always just putting it on an RCBO, you know, like a Proteus double pole bidirectional RCBO, because they're so accessible now. It's not much ag to do, about 13 odd quid or whatever, and you can get around that. But actually, you come across these sort of issues, and you think, actually, this shouldn't be on an RCD. And to go right back to the start of why we're looking at this, the problem we've got is that obviously solar inverters like that Solis that you had, and you mentioned to me off camera that, you know, the panels are a little bit leaky and all this sort of stuff as things are out in the weather, you know, in the sun, in the rain, in the snow, you know, water getting into places and creating those paths to earth and all this sort of stuff, and the inverter also kind of breaking down a little bit and creating all these paths to earth. If you've put that inverter or that battery on a 30 milliamp RCB or RCD, then you've got quite a low threshold because it's going to trip at maybe like 15, 17 milliamps. So it doesn't take much to actually start nuisance tripping that. And if you've chosen to run your cabling, this is on any, you know, earthing structure, TN earthing or TT. If you've chosen to run that cabling within the wall, you've got really no option unless you've had some sort of, you know, steel wire armor or whatever. But that's why we try to surface clip a lot of this stuff unless it's an exact requirement. But that's where you start to get into this tricky situation of then suddenly having to put that on an RCBO at 30 milliamps.
Yeah, I mean, it could be an existing setup that you go into that somebody else has put in where the inverter's failed, and you might have a twin and earth cable that's buried in the fabric of the building on a TT system. And because of that, you're going to need that 30 milliamp RCD to protect the cabling in the wall. Now, if you were to make the decision of swapping that inverter and then taking responsibility for that circuit, you could deviate within the electrical certificates to say that you'd used 100 milliamp RCD to give you the protection that the inverter will work to. Probably the better option would be to get an inverter that'd be happy with a 30 milliamp RCD. But you raise a great point that lots of these things naturally leak anyway, and the limit of 9 milliamps of where we should be sitting these things as a maximum for kind of parasitic, for want of a better word, earth leakage is really hard to achieve with PV, especially. And the system that you just mentioned with that Solis inverter, it was an old FIT system. Panels had been up 15 years, doing a great job, generating lots of renewable power for that homeowner, but obviously it's 15 years of weather up there. We don't know the condition of the MC4s. We tested the array out and it seems to be in good order, but it was a dry, bright, sunny day. The RCD wasn't actually operating the day I went. It did it every 6 weeks or so.
Classic.
Yeah, so I mean, it's one of those where there's probably a latent fault within the PV system, but is it something that necessarily needs to be fixed? It's probably leaking at occasion maybe 20 milliamps, which is just enough to upset that 30 milliamp RCD. The Solis inverter that was installed was quite happy to be on a 30 milliamp RCD according to its manufacturer's data sheet, but clearly it was tripping of occasion. The RCBO tested out fine. So there's kind of the difference between a fresh install that's under your control as the designer and then trying to get systems back working whilst not bending the intent of the regs. And with TT, you know, it is a little bit of a sticky wicket sometimes because we all fall into that mindset, and I've done this, that TT just needs 30 milliamp protection. That's kind of the mindset we get into when, you know, the reality of it is a bit different to that. And if you're not in the regs book all the time, monitoring all these changes and understanding what's going on, you know, it's easy to get confused. You know, I asked this question, I'm going to be very honest. I reached out to Neil Bridgman, who I know deals with RCDs a lot in rail, and the guys on the Apprentice One-to-One podcast when I was going through these kind of situations myself for their input, and just a second check myself, really, beyond the regs. I think that's really important. And like you said, that's where this podcast will hopefully be useful to other installers as their second check as well for these kind of questions.
You do need it reinforcing sometimes. I mean, I'm more than happy to kind of describe where my head was at with all of this without looking at any of the regs book or anything. Was 100 milliamp for distribution, so you could have that selectivity, and 30 milliamp for final circuits. That's where my head was at with it all. And you know, for in most cases, we try and put everything. We try and keep a lot of this kit off RCDs. Obviously, TT is a different kettle of fish, but certainly on TN systems, we try and keep these systems off RCDs because of the tripping issues that they can have. But that comes down to the equipment, the installation, and lots of other things. But yeah, I mean, these if you take off the covers of this stuff, it's just electronics. So you're going to have huge, like in relation to the RCD, like a 30 milliamp RCD, you're going to have huge amounts of leakage, probably straight out the box. Never mind when it gets a bit older and things start to become a little bit more leaky. So it is a hard line to walk, but equally, it's great to have this conversation and try and even just for myself, very selfishly, have this conversation and actually kind of re-educate myself on it and basically go back over what I've probably been taught, but I've fallen into the trap of becoming comfortable with my my kind of, what would you call it? My kind of influences that I've put on myself where I'm like, yeah, so that's the standard rule for that, that's the standard rule for that, until you hit a problem where you're like, oh, actually, I can't do that now because this piece of equipment will not be happy on 30 milliamps. And yeah, so that's really interesting. And the other part of this is when we fit in battery systems, especially, we now have to be aware that that's a bi-directional power flow. So part of our conversation about the SIG&STOR system was that it obviously charges and discharges as all the batteries do. So the SIG&STOR's got a 30 milliamp RCD built in.
It's those electronic varieties,
RCM,
but there is that in there, yeah.
Yeah, so that's that. Depending on how you view that in the regs, obviously, I don't know if it's got the BS number for it. No,
not presently.
Yeah, so how you, if you're happy with that, relying on that for the discharge, but obviously that's not protecting the cable from your DB into the battery when it's charging, because that bit, it's only going to hit that RCM unit in the actual battery when it's going the opposite way. So it's trying to be clever about how you supply that circuit. And let's be honest, there'll be a lot of these that just get banged out, and there'll be just on MCB on a on a TT. But if you're responsible for on your electrical installations, this is the sort of stuff that you probably need refreshing on, unless you're doing it day in, day out.
Yeah, I mean, if you think of the battery storage systems, wherever you're installing it, whatever the earthing system, overnight when they're discharging, I mean, it'd be discharging on and off through the day as well, but we'll just go for overnight because that's an easy example to think of. That flow of energy on its circuit up to the gateway or consumer unit has no RCD protection that would satisfy our intent of the regs. With the 61008s and 61009s, it's relying on the technology in the inverter. And there's loads of other clever monitoring in there beyond just RCDs as well. It's probably way safer than it is with those RCBOs and RCDs in a distribution board that we're traditionally used to. But in terms of BS7671, that is a grey area just for that bit of cable leading up to gateway. Obviously, after that, you're still going through your final circuit RCBOs. So you've got that within the rest of the install. But so it really depends on how that circuit's installed. With a TT, I think the best way to look at that is how these things should be installed. So you've got a new TT system to meet the intent of the regs as they are now. Really, you'd want a 100 milliamp time-delayed S-type RCD, and that would protect your tails going into your consumer unit. Now, that's not essential, because if you've got a gland that secures the tails and you're happy that there's no potential for them to kind of interact with that enclosure kind of secure, you can potentially do away with that. There's some great guidance out there in industry already around that topic. So it's not essential, but personally speaking, as a designer and installer, I would always fit a time-delayed 100 milliamp S-type RCD up front. And then your final circuits for power, for lighting, and all of those things would be 30 milliamps. And we'd probably do that for any final circuit, to be fair, without thinking. I'm just saying if we was putting a heat pump circuit in or an EV circuit, you'd go for a Type A 30 milliamp RCD, when really, if we delve into the manufacturer's instructions, that's not always going to be the case. Some might want a Type B RCD at 30 milliamps. Some might want a 100 milliamp RCD. And the manufacturer's instructions are really clearly set out in the regs that we need to be led by them on this, around RCD protection as well. It references it quite a lot as a shall rather than a should as well. So we do need to be paying attention of what they're saying. But once we've made that decision to put a 100 milliamp RCBO in, if we use that as an example, for a solar PV inverter, and we're happy that we've got fault protection from that, we've installed our cabling in a way that it doesn't need additional protection. So we'll say steel wire armour on the surface of a building, it's just running straight to the inverter. There's no need for additional protection on it. That's fine. But then you've got to look back again at that source RCD, because if you've got your 100 milliamp Type S, really you should have a 3-stage increase between that 100 milliamp to the one at source. You'd need to be looking at swapping that for a 300 milliamp time-delayed RCD as well. So there's two different changes there. And the basic principle is that if that inverter goes faulty, you don't want it taking out that source RCD of the time-delayed variety and taking the whole installation out. You'd much prefer for that to happen on the RCBO feeding it, or the RCD that's protecting it. So that's why you'd need to change that. There's a potential there, even if it's time-delayed at 100 milliamps for one, to trigger the other, and you get unwanted outcomes.
Yeah, so basically saying there that even, so if you have, because I'm pretty sure, I mean, if an inverter trips, or some inverters trip a 30 milliamp RCD, that a heat pump is going to be there as well, because there's going to be there's compressors, there's the electronics, the fan controls, all that sort of stuff is going to be leaky, and it's got water in it, or a liquid, so it's going to be leaky as you can imagine. So if we've got an installation and we've got the 100 milliamp time delayed RCD up front, and suddenly we're having to introduce some other 100 milliamp final circuits, we are then looking at potentially having to change that 100 milliamp time delayed to potentially something like a 300 milliamp, so that we've got almost like a staggered
selectivity of your RCDs.
Even though it's time delayed, dropping it down to 300 milliamps rather than kind of just giving it that something like 200 millisecond time delay on it. Yeah.
I mean, that was Neil again who kind of raised that with me, and it was a great shout because I instantly thought, oh, it's time delayed, so that one will sit there while. But it doesn't always work like that with earth leakage, so it's worthwhile having that. And to have a 300 milliamp up front of everything, again, you need to be looking at what your RA value is, your ZE value for that electrode that you're using. It would have to be lower again than 500. You were right on the table number, it is 41.5. You'd have to look at what it said in there for that particular type of RCD. But, you know, most cases, we would be within the realms of that anyway. We're trying to get under that 100 ohm limit. And if we're generally installing battery storage systems, we're looking at electrodes lower than that even further because of the way they behave when they're islanding. So the chances are we've got a pretty stable and low value on the electrodes within the installation anyway. So we'd be able to do that. You know, the other side of that is that you could make the engineering decision that, okay, I've got a nice tail gland, I've cleated my tails up on some Paxilin, I'm happy that they're not moving about, they're securing straight into the main switch on the board. It's a nice Proteus main switch as well with 2 terminals on it. I don't think they're going anywhere, so I'm going to remove that upfront time delayed RCD protection from the tail scale. I don't think I need it. I've got 30 milliamp protection on all of my final circuits for both fault and additional protection, and on my inverter I've got the 100 milliamp RCD RCBO sat there to give me fault protection on that piece of equipment, and the cable installation method doesn't need additional protection. So you'd satisfy the intent of the regs either way around with that, I think. And that's the important takeaway from all of this, is that, you know, you can install this stuff and still comply with BS 7671. It's not so much a deviation, and I think lots of that resides in understanding the difference between fault and additional protection. And I have been going on a learning journey of that myself, because we do fall into those traps and bad habits and rules of thumb of just looking at 30 milliamp protection.
That's basically where I'm at. That's what has sparked this full conversation, really. And it's just ironic that we've both had this similar things come up in our working day that has made this topic even more important to just us. You know, forget about everyone listening or watching. This is just an important thing that, you know, even just me and you understand. And I've just found the table there, 41.5. So 30 milliamp is that 1667, which obviously is caveated to, you know, is it anything over 200 milliohms might be, I think the on-site guide used to say that, anything over 200 ohms, was unstable. Yeah. But then it drops, then 100 milliamp is 500 ohms, 300 milliamp is 167 ohms, and then 500 milliamp is 100 ohms. Most of that is achievable. I mean, most of our earth rods are kind of around the 70 ohm mark or less, tend to be. I saw some really interesting stuff with Azuri Electrical that had been promoting the Conjudisc and the Earthing Services company. Unfortunately, I missed the webinar that they were putting on, but they were getting some crazy low results with the Conjudisc, with the Conducrete and all of that to really lower that impedance there, which is fantastic. And maybe more people will go down that road with needing lower and lower kind of values on the rod.
Yeah, we had them do a great service, by the way, if you've not used them before, where they will design remotely how many Conjudiscs you need in a certain area to achieve a set value of RA, and they do that from geological surveys that have been done and the records they have based on the postcode area you're working in. We had a new build site where it was actually prohibited to drive electrodes into the ground. It was a really weird one. It was in around Peterborough somewhere. I've forgotten the exact area. But he wasn't allowed to do it, so we'd looked at Conjudisc for that reason. And when I approached them just to buy one Conjudisc, because that's all I wanted, they was like, well, what's your postcode? What are you trying to achieve for the value of resistance? I was like, why do you need to know all that? I just want a disc. And then they explain it to you, because, you know, you're ignorant to a lot of these stuff until you actually start to think about it. And they said I'd need 3 Conjudiscs to get the value that I needed in that area. And initial reaction is, yeah, mate, whatever, I'm sure. But I ordered the 3, and I was glad I did, because we ended up needing them. You had to kind of set them out to get, I think we wanted 80 ohms on that one. That's what we'd targeted. So it does depend on kind of the ground conditions where you're installing this stuff. And I've actually got a conduit disc on my house, and it dropped down to like 40 ohms. I'd had electrodes on there that are, like you were saying, around kind of 80, 90 ohms. And that's just one buried not very deep in the ground with a bit of concrete around it. I'm sure if I tried harder and dug a bigger hole, it'd get lower.
Yeah.
So it's all using all these things to help us. And yeah, it makes a lot of sense, doesn't it, to have a good, stable, reliable electrode that this system sits on, because when something goes wrong, that's the fault path.
Yeah, and we've seen it in the update on the regs that we should be starting to really consider putting these on TN systems as a supplementary. So you kind of, yeah, it would be really interesting to get them on, to be fair, and maybe do a podcast with them, because just to explain the technology around it, because I've struggled to kind of think, well, this thing is fairly big, but a rod makes more sense to me because it's kind of like, it feels like it covers more distance. But it'd be interesting to have a chat to them about the conduit disc and learn a little bit more about how it actually achieves that much lower reading. It's probably to do with the concrete and everything like that as well. But yeah, it's really interesting how these problems in industry get solved by innovation like that, and hopefully regs can keep up with that, not necessarily with the conduit disc, but in other elements like the RCM units that are in the battery storage systems and what have you, to try and give them some sort of stamp of approval, just so that we don't have to stress about that as much. But we've mentioned things like that before, where regs are a bit slower to react to these sorts of things in sort of updates and what have you. So it'd be nice to see those kind of get that rubber stamp in the regs. It's
just how this stuff crops up and then we deal with it, isn't it? And the concrete is a really weird material, by the way, if you've never handled it. It's a really odd thing that it's like it's not like cement. You'd expect that like sticks to you, and if you put your hand in it, it sticks to you a little bit. This is like really soft and squidgy. It's hard to explain. It's
like bread.
It's weird. It's not like a dough, but it's a really weird material. And then obviously once you wet it and it sets hard around the disc itself. And they're considering things as well around the actual termination onto the disc. So there's like a two-part resin essentially that sets around the terminal on the disc itself. So that's something with electrodes. That's the point of failure, isn't it? Where you actually clamp your cable onto it. Even if you put a pit around it, there's still all of the insects and stuff that are going to end up getting into there, the weather washing through it and all the rest of it, and eventually that will corrode and potentially cause a weak point in the earthing system. With those discs, having the terminations covered and protected is quite reassuring, I think. So we're a big fan of them. It removes the need to start driving rods in the ground anyway. So even on TN systems, they make a lot of sense. The only trade-off to that is they're very expensive. But I guess that's like everything. You get the value from it. It's expensive in terms of buying it off the shelf, but for the hassle and aggravation it saves you in driving a rod potentially through a gas main or a water pipe, it's a cheaper solution in the end, isn't it?
Yeah, absolutely. Yeah, I mean, we've had instances where we've installed a system and it's had backup enabled on it, so we've put a rod in and all of that, and then I think we went back to add an extra module to it, and we just did some testing and what have you, just verify everything was still okay. I'm like, this earth reading is mental, like it's really high. Went out there, and the clamp onto the rod had just split, and it was just laid in the pit, completely disconnected from the rod. I'm like, there's no way we left it like that. There's absolutely no way we left it like that. But all we could kind of put it down to was that there must have been, when we've tightened it on, there must have had like a hairline crack or something in it. Water's got in there, potentially frozen, and obviously expanded and cracked it, and then it's heated up, and with it being metal, kind of expanded, contracted. It just basically, you could literally, it's like a clean cut straight through it, both sides, laid in the pit. And we're like, if we hadn't come back to put that extra battery on, and let's face it, not many people have their electrics checked, in sort of the 5-year interval or whatever you've kind of put on that job, that could have been laid there just ready for power cut and not actually having any type of connection.
It's scary, isn't it?
Yeah, it is. It's the sort of stuff that makes you not sleep at night. But
I think that's the ever cheapening of materials, isn't it? You see it with the nuts on your steel wire armour glands as well. We've had them split on us. just get thinner and weaker. It's the same with those. I mean, what's an earth rod cost? £3 something?
Yeah.
The clamps are next to now either.
Yeah.
Really, we should maybe be thinking about putting stuff that's a bit more robust when you're looking at it sat there unchecked. Because like you'd said, I wonder what the stats are around how often domestic homeowners have their electrics checked. It's definitely not every 10 years, I'm sure of it. So these things could be sat there a couple of decades, and you want to give it the best chance, certainly lasting longer than a couple of years.
Yeah, absolutely. I mean, just lately, some of the councils have got in trouble for not having their properties checked, on the EICRs and that's a council that is literally driven to do it. It's like in rental. Obviously, rentals, there's fines and even prison sentences for people not keeping up to date with their electrics being checked. But domestically, there's not really any pressure to do it, apart from maybe a bit of insurance pressure if something happened. So yeah, that was quite a sweaty moment when we saw that. We thought, oh my God, how long's that been like that for? But it can happen, and like you say, potentially the weakness of that that piece of metal has caused that, and potentially, I don't know, us over tightening it. But it's so hard to know with that sort of stuff.
When you think of a TT system, that could all be sat on that one connection. All of your design calculations and staging your RCDs and thinking about all of this stuff falls back on that one rod in the ground. Maybe even at a domestic level, we need to be thinking about having a couple kind of redundancy, if you like, in the system where there's maybe two rods. With TT, I know we're in quite a rural area, aren't we, Sam, where we operate. There's lots of agricultural premises and people who live in villages without PME earthing systems. It's reasonably common around Driffield. And I'm trying to think of homes that I've gone to which have had more than one electrode, and there ain't many.
No.
And sometimes they're still off the old pegs that the DNO used to knock in the ground, and they are pretty much like a steel tent peg, that kind of long. And they're just knocked in the front garden outside a window somewhere, and they've probably been there 30 years. I think, Jesus, we go to all this extent with the way we design systems, and we're pinning it all on that working.
Yeah, that's right. And the difficult thing is that if you offer something like Condudisk, everyone you're up against will not be offering that. Now, that doesn't make it right that they're not offering a better solution, but the customer doesn't know that is a better solution unless you physically get to show them why it is and it isn't. And if you're doing that for the battery system you're using, the panels you're using, the inverter you're using, suddenly that's like a 2-day conversation with them, because there's a lot there for them to spend, even if it's just an extra £500,000, whatever it is. So it's that constant juggling act as a company, isn't it, of trying to do the best for your customer, cover all the regulations, hence this conversation, but also win jobs to keep the company going. So it is a tricky one. But the other complication, I suppose, is us going to plastic services. All the services are now plastic, pretty much. Water pipes, gas pipes, all that sort of stuff. They're all moving to that, and so we're removing what probably was our redundancy back in the day, because we're actually for cost and for ease, we're removing that, and longevity, removing those metal services, which were basically the earth rods or supplementary earth rods back in the day to create your parallel paths and lower that reading down. So that's potentially a bit of an issue. And I'm not sure if that was behind why they're wanting people to put in the additional earth rods onto TN systems now.
That's the conspiracy. That's like the Elon Musk and Donald Trump to everything to make it political at the minute. That there's the rumour mill there that the PME network is not in the condition it should be, and as you've just outlined, a lot of the services that would traditionally support it and also send diverted neutral currents between premises is a drawback to that setup, are now gone or going. There was a time in the regs where your water pipe could potentially be the main source of earth to a property, and that was allowed to happen. Kind of got changed through the additions, but we still find the odd one where it's still sat there with the main water pipe as the only point of earth to someone's home, and then you've got to deal with that, because the DNOs will argue, well, we never supplied an earth to that property ever before, so we're not giving you one now. And you're looking at converting that to TT. So that's just more wider problems as electricians rather than being renewables based. And as you've just said, trying to do it in a way that satisfies the regs and keep people safe is great, and we certainly do that as a business. But we do lose out on jobs where I know full well of the contractors are not taking that into account. They're not pricing it. And I bid on a price we'd done last week, and I got told off by the accounts manager in our business, who's also my wife, for responding in a way she thought was unprofessional over email with that particular customer, because I thought they'd been a bit rude in how they kind of explained that to me. Just by saying, when you do eventually have a problem, because I knew this installer wasn't, they're not very good, you can always come back to us, kind of thing. And she's like, you sound a bit bitter, you sound like a sore loser. And that's the struggle, isn't it? Because we know that's how it sounds, but it's so frustrating, because we also know that people can't price things at the level that they are and do it to the standard that's needed. And it's explaining that without sounding sour. And I got it wrong on that occasion, I'm happy to say, but it was just one too many.
Yeah, I'm leaning into the bitterness now a little bit, because, it is and this isn't necessarily bitter towards customers, because some customers knowingly go into a project with a company, knowing that they're the cheapest, knowing that they're probably not going to get the best job, but hoping that it all works out. And that's kind of on them, and that's their risk. But there's other customers there that kind of see all contractors as equal, and they just want to know, right, for this spec kit that does this, that generates this, that has this much storage, what is your price? And you can't necessarily blame them for that, but it's everything else that comes around that. Is your bonding in place? Does your DB need changing? Do we need some more additional or fault protection on the property? Do we need a conti disc? Do we need all this other stuff to really satisfy the regs? And they're normally the bits that are adding the cost to the job, because you've got the components, but you've also got the labour time to fit those extra components. And you get customers that know the value of that and want to spend the value in that. But you have the other ones that don't want to potentially acknowledge that there are those nuances with different companies where they're actually looking at something in a wider range, and they're actually looking at, well, actually you need your earth bonding doing. Whereas will another company realise that during the install and go, oh, sorry, it's going to be an extra £500 for your bonding now. There might be an extreme example of how much someone would charge, but sometimes I think being too honest up front and being too clear and being too kind of specific on what you're going to do can sometimes cause you downfall. But it's a really hard balance, because for some customers that will make them have full confidence in you, and for others they'll go, all right, thanks very much. Company B, can you do that for me? And they go, oh yeah, we'll do that for £200. And so it's a real hard balance. And so I'm leaning into the bitterness a little bit, because I'm like, I am bitter about it. I am bitter that we're getting beaten on pricing by companies that maybe don't want to do it in that way. And that's on them as a company, and that's fine. But for me, I'd never want a customer to ring me back saying that basically someone's been hurt, or we've just had an inspection done and you've done this wrong or you've done that wrong. Like, that's a massive fear for me, because it takes years to build a brand up and build kind of a reputation, but you can lose it like that. It only takes one incident to happen, that to go on to the new world of social media, and that is your reputation done.
Yeah.
And so that terrifies me. But this podcast isn't designed around us promoting our businesses, and that's not what that is. That's just a real world scenario of what we both face in our businesses, and probably a lot of people listening to this. Because let's be honest, people that are listening to podcasts about their industry are probably the ones that really, really care about it, because otherwise you maybe wouldn't be that bothered about trying to learn more about it. It is a challenge, but it's not just renewables based. It's across plumbing and heating, gas, building. Across every industry, there's always those challenges. Yeah.
I want to come back to the inspection thing in a minute, because you've had some other content out this week that I want to mention. But before we get back to that, you made a lot of great points in that little segment, and the customer education piece is really important. I think there's lots of installers, if you've just said maybe watching this, and others out on the social media things, that are really trying to explain that, to push that message back into the consumer base, that there are differences and you do need to do your homework on it. And just to go back to the job that I'd spoke about with that Solis inverter, that was an issue on the TT system where it was tripping the 30 milliamp. RCD, but some other work that had been done there was the installation of battery storage with batteries in the loft, and that was done 6 months ago. It was a job that we also priced and didn't win, and I'd left that customer on better terms than the one I spoke to last week. So that was where they got back in touch with me. And some people had said, well, why do you even go back? You shouldn't bother, like, just cut them loose. They didn't want to pay back then. I just think some people just don't know, and they've got to go through that experience. And if you have that attitude, then nothing really ever gets fixed, does it? So we went back to look at that, but that was a circuit that was wired in twin and earth cable, installed through the fabric of the building, so it was buried, didn't have any RCD protection. It was just on an MCB in a plastic insulated consumer unit above the solar one, and the batteries were in a loft, sat on what are like lats from a bed that they look like they'd just found laying around up there. The timbers in the loft were really thin anyway. It was kind of, when you get into a loft hatch and you feel it move a bit. The batteries were right there next to the hatch, 2 of them. And then the inverter mounted. You're looking at it, there's cables everywhere, buried under insulation, the battery ones. They run pretty warm anyway, don't they?
Yeah.
And you think, this is just waiting for something catastrophic to happen. How can installers knowingly do that in a place people live? And it's all well and good consumers should educate themselves, but why should they? I don't educate myself on every safety feature of a car. I just assume that it's been made right and that all have differences in what they can do, but the safety function is largely similar. And I think there should be a much more level playing field to all of that. And we've still got the argument of has been guidance or been enforceable or not. But yeah, it's just a bit of a pill to swallow seeing that. So you had the RCD set up wrong in 2 different ways on that job by the same installation company who the customer had tried to ring. They didn't respond to them, didn't get back to their messages, didn't respond to emails. They're still trading, MCS registered, HICE insurance policy in place. Customers been in touch with all of those people with no help.
The difficult thing with that, and I know you want to come back to that inspection point, so I'll come back to you on that.
Cover it
after.
now if you want, mate.
Well, no, I'm just going to say on that, because this is something that I've pondered when we've had similar things happen, and you kind of go, yeah, they've come back in touch with us, and that's probably now a customer for life that we've now got. But that other company that has fitted that battery system has walked away with the cream, because there's the job, no matter if you've lost it over £500 or £1,000 to another company, no matter how much repair work you do there, you're never going to recoup that cost that the profit that you've lost out on there, but you're having to deal with all the problems. And so for me, I'm like, they're happy sat there with that, £1,000 profit, 5,000, 10,000, whatever the amount is that they've earned profit, knowing that now you're handling their problems. And so that for me is a really bitter pill, because we had a similar problem on an install where we'd done the solar, the battery. This guy had spent thousands with us, like it's a really big system, fantastic, top of the range stuff. And then he didn't want to use us for the EV charger because we were, I think we're like £500 more, and it was quite a distance for us to travel to do it. So a lot of it was travelling costs, to be honest. And this charger got installed, and where they connected the charger in, it was after the gateway, before the gateway, so the system couldn't see the consumption that this charger was consuming. And so the customer got back in touch with me after this install and said, basically, this has happened, sent me the photos, could tell instantly what the problem was, and basically how much would it be for me to come back out and basically reconfigure it so that the charger could be seen by the battery system and everything like that. And the only thing that I could actually come up with was the same price that we originally quoted, because if I go back and do that, make any changes to in this case the EV charger, that is now my job. If anything happens with the switchgear that I've used, or the cabling that I've used, or even potentially the charger, because they maybe don't have any faith in the old installers, that's going to be my headache to sort out. But I'm sorting that headache out for a tiny profit, and I've also removed the after sales of the company that did install it. So I was sat there in the office thinking, well, what should I charge? Should I charge like a £200 call out or something like that? And I'm thinking, well, I'm going to make 25 quid profit on that, but I'm taking all of that responsibility away from the company that has installed that. So I'm not saying I would have done that on a solar and battery install, but part of me is thinking, maybe I should. Maybe I should go, well, I'm now effectively coming in. I know you're probably going to use us in the future. Therefore, we're going to be now responsible. And you talk about it a lot, Mark, about the risk, pricing that risk in. And I'm kind of looking at that thinking, I need to price this risk in. And this risk is basically the system now. So should I be pricing it at that level? And that might sound extreme, but when you actually start really thinking about it, thinking, well, no, I'm actually now removing all of that risk for that company. And you mentioned that company is still trading. I'm thinking, well, I wonder how many other installs an install that does the right thing, wants to get the system back running for the customer, maybe feel sorry for them slightly and wants to get, them up and running again, has actually taken all of that risk away from that company that originally installed it, walked away with the cream of the profit, and then they can put that money into more Facebook ads, more this, that, and the other, get another job and do exactly the same there. And so in my head, I'm like, maybe we need to rethink, like, when we're taking these jobs on, how much we actually charge for these.
Yeah. And it's exactly the chain of thought I've been going through with this specific circumstance. It's we've only had a couple probably. You've been in this game a lot longer than me, so you'll have way bigger experience and exposure to that. And in this case, I've kind of directed the customer to keep going at that company to get them to resolve it and to actually get MCS and Heist to engage with them, because it seemed a bit like they'd been brushed off. Obviously, I've only got the account from the customer's side. I don't know the ins and outs of what's been discussed, but my advice to them was to get them back, get them to resolve that problem, because for me, where the batteries and inverters are nothing like accessible enough for maintenance. They need to be out that loft and moved. There needs to be some rework in the way the circuit's configured, supplying the equipment. And the reason they put it up there, it's quite a difficult property to locate that stuff in. They've taken the easy option, taken the money, as you've just said, most likely. This is kind of my view from afar, if you like. There's kind of a little ditch in front of the house that's public right of way, so they couldn't put it there. Down the side, there's a shared driveway that they're not allowed to put anything on. Around the back is like a little courtyard where they've got greenhouses. It really would be difficult to site that stuff outside, and inside the property, even worse. So it should be something that they're made to resolve. I think they need to go through that pain point to understand that they can't keep doing that. And reading between the lines with that particular company, I think it's probably quite common in a few of them that carry on like that, is they're so busy with sales and installations that they've got no aftercare, they've got no customer support, and they are relying on the likes of us or other electricians going out and snagging those jobs for them, taking all that responsibility while they just keep going. And, that's been my approach with this. I could have easily said to that customer, this is a price, we'll sort your batteries out, get them out of the loft, redo the cables. It could probably end up being thousands, to be honest. They need a new consumer unit as well. And it's work for us. And I'm pretty confident they would have just paid it. But I don't think that actually solves the problem in the right way. So we've kind of pressed them to go down those avenues. Whether it ends up playing out like that or not, we'll probably end up being back there sorting it out. But, we can but hope.
Yeah. And that is the moral, I think it's a moral challenge. I think if you were just basing it on the business case for it, you go, well, I'm taking the risk on. I need to be, the risk is something that I need to factor into the business, that when something goes wrong, I need to have the money in there to go back, this, that, and the other. You may charge if it's not been your job, to go back and do call outs, because you're kind of one step back from it. But it's maybe when you look at it morally, you think, oh God, they've spent 10 grand on this and now it's not working. And all they need is me to just reconfigure the acid. Oh, I'll do it and I'll just charge them for that. But then, so it's like this battle between your head and your heart, isn't it? A lot of the time, going, well, no, we need to charge this because it needs to be done properly, and we're taking on that risk. Or, quite rightly, and we've done this in the past, and that was my solution to when he wasn't happy to pay basically the cost that I originally quoted. I said, well, your only other option is to raise this with the company that fitted it, because they've been paid for the job and it's not been done correctly. And pushing that back through, obviously, with it being an EV charger, there wasn't MCS, but pushing it back through this company to go, look, you need to sort this out because it's not working in the way that it should have been working. I'm not sure where I ended up getting to with that. I think it's still as it is, but that's maybe an education piece for us as installers, not to maybe just fix things and take on that risk ourselves, but to actually have a little bit of a rebuttal when these jobs come in and go, you know what, something needs to be sorted here. And that was, I think, potentially leading us on to what you were going to talk about with this inspection.
Yeah, I mean, it's just this post you'd shared on your LinkedIn and Instagram that were both terrifying but also encouraging.
Yeah.
So you had a bit of an inspection.
We did. Yeah, we got contacted by MCS and said, by the way, we're going to this site. Please arrange access. And we're like, okay. Okay, yeah, we'll do that. And so we arranged that. They never asked us to attend or anything like that. And we arranged access, and then you basically, the day they're going because you've arranged the access, so you sort of sat there next to the phone like, right. And emails thinking, I'm sure there wasn't anything. Did we put that DC cable label sticker on that, or did we need to put ringing up the lads? You did put a dual supply label on that. Trying to think about all these things, and fortunately, it came back with no non-conformities, and we just need to provide a few photos that they couldn't get access to on site because of safety, and I didn't want to shut the system down and all this sort of stuff. So yeah, but that was really encouraging because on an earlier podcast, if you haven't listened to it already, we spoke to Ian Rippin from MCS, and he was going through the changes that MCS are looking to bring in to basically support good installers. And I did a bit of a story after that about it, with them starting to factor in risk and how likely a problem is going to happen with that company, either by some poor inspections that they've had in the past, where there's been the sort of major works that needs to happen, and therefore them getting more inspections each year to try and make sure that they are complying, or if it's based on they just simply do hundreds of installs a year, so the risk of them getting a bad subcontractor or something happening that they need to be inspected, even if their inspections are satisfactory for the majority of them. And I believe we're going to speak to Ian about all of this soon, I think. Aren't we? I think he's booked in soon.
Yeah, Jess has been squirreling away organising that, hasn't she? I've seen the emails bouncing around.
Yeah.
So hopefully we get a conversation with Ian about that. But I think that's really encouraging. You would be scared if you had that message. I'd be like thinking the same as you. I hope we've not done something stupid that we're going to get caught out on. I mean, obviously no one goes to work to do a bad job, but we're all capable of making mistakes. But then you think about it with a bigger picture, and the installs that I went out to fault find on this week and the one the other week as well, you think, well, okay, if they catch those installers and they see that themselves, maybe they can start to do something about it. And a lot of the complaints that we have proposing systems to consumers fix themselves because those kind of contractors either have to raise their standards or they get removed from being able to operate through a scheme like MCS.
Yeah, absolutely. And I think it's, there's sometimes, and I'm massively guilty of it, thinking that there's just these bad actors out there that are just there to rob everything. And I think sometimes, a bit like this RCD chat, you can fall into the fact where potentially a couple of people have started up a solar PV and battery storage company. They're sales based. They maybe rely on subcontractors. They're maybe not kind of absolutely all over the detail and the regs, and they're relying on these NIC, NAPIT, whatever bodied electrical firm to fully complete this installation to standard. And even though it's not their name above the door, they're relying on this subcontractor to install that work. And so those business owners are kind of been let down by that subcontractor. Now they're not without failures there, because they should be making sure that stuff is happening correctly. But when you're only inspected once per year, and this was on reflection, this was kind of where my head went, that if you're only inspected once per year and you have a pick of 3 jobs, unless every single job you do is terrible, you can probably find the least worst job to take them to. But when they literally pick out of your list one and say, we're going to this job, I don't know, and we can maybe ask Ian this, I don't know if you can make a really valid excuse on that, like if it is a really bad one, or if they basically say, look, you need to take us to this job, this is the one we've chosen, this is the one you have to take us to. That means that there is no wiggle room. Even if it's, a month's time, we are going to this job because this is the random one that we've picked. that's really powerful, because then that doesn't allow any flexibility when you're thinking about your inspections. You're thinking this could be the one that they just choose, and I can't wriggle out of this. So it'll be interesting to chat to Ian about that, to see how firm that site is really.
Yeah, and how often they're doing it as well per contractor. Is this something we expect once a year, once every 2 or 3 years? Are they going to do it on a risk-based approach, where if you've had one of these surveillance visits that like, they're okay for 5 years or whatever, we stick with their annual audits? It'd be really interesting to get to the meat on the bone behind that, and I think it can have a real positive effect, because you make a great point around installers in that example, but there'll be other ones out there who've gone and set up themselves and been on manufacturer training, and a lot of these manufacturers told installers you can put batteries in lofts. They delivered that training. You can be told that the inverters have got all these clever RCD technologies built in, and you're maybe not as on top of keeping up with the regs as you should be, aside from going to do your update course every 5 years, multiple choice exam, and there'll be a large number of people going to work on that basis, not wanting to do a bad job, but maybe not knowing what a good job should look like. And those kind of surveillance visits where they've got MCS saying to them, well, actually, we've got this PAS document now, and while it is just guidance, we'd like our installer base to implement it. It's going through draft for public comment. Are you aware of that? And they can do education pieces. It's not about just catching everyone out and removing them. It's trying to level up those standards, I think, to give consumers a better service and stop the solar coaster, which we did well to not mention in this episode until then.
Until now.
So I think there's a lot of good things to come with that, because we'll all make mistakes. I'm sure we'll do installs that get snagged by MCS or others at some stage where we've got something wrong, and we'll hold our hands up to that and take the learning message through it.
Yeah.
I think that's the important piece. We're not sat here lecturing industry that we know better than everyone else, hence asking the question about RCDs. This is something that I didn't know the answer to off the top of my head when you first, I think, asked me, and then I was like, well, yeah, I've got this circumstance as well, and you start second guessing and asking around. You don't need to know everything. No. You just have to have the willingness to go on those learning journeys and pick up that knowledge where you need it.
Yeah, absolutely. And suck in a bit of pride sometimes and go, I don't know the answer to this, and I should know the answer to this. And that's the same with these audits, these surveillance visits. It's kind of like, I put it on the post that I did about that visit. I am sure that over the next 10 years, there will be a surveillance visit where they find something, because ultimately we can't, everything can't be absolutely 100% every single time. We can strive for that, but people have a bad day, equipment fails, you maybe have used a subcontractor that didn't have the same standards that you're not using anymore, and you've missed that they've done something, or I can't see it being ever anything major, because we are, speaking for Oval now, we are very, very particular on how we do things, but it'll be, I can almost guarantee it'll be like a labelling thing, or it'll be something like that, which you can argue if that's major or not, but, I'd rather be picked up on that than a panel swinging around off the roof kind of thing. And so, yeah, there's definitely going to be something over the next 5 years, but I'm kind of okay with that, because if I know that we're getting inspected every year, every 2 years, every 5 years, whatever the sort of regularity of that is, I know that others are in that situation as well. And hopefully the companies that are maybe in it for the wrong reasons are getting really hammered with visits, and hopefully they're able to lift the game up and still be in business. I don't wish anyone out of business, but hopefully they're able to take that as we are really struggling here to get the quality. We need to hire some other people to look over this, pay more money potentially, and that will hopefully as well lift the prices that they're charging as well, because they're paying more for the people doing the job. So it's a tricky topic to tread this, because I don't, like you just said, I don't want to feel like we're kind of lecturing people to say that, basically follow our standard or don't, because there's some absolutely unbelievable installers out there that I've worked with, I've seen. I'm just like, we have got to really step up our game if we want to be toe-to-toe with these guys. Across the country, some awesome installers. We are definitely not the authority on this. We're just two geeks that like talking about this stuff. But yeah, if the MCS can really raise the standard across the industry, hopefully that lifts that playing field, that bar up to be a bit more even, so that we aren't just sat here in 5 years moaning about poor installs being that poor. They may be just a couple of % poorer than they should be.
There's a cost burden there for MCS as well, isn't there? Because if these companies go out of business, so they get caught doing quite bad work en masse, then they're more than likely to fold, and then it's them picking up the pieces. So it's encouraging, I think, to see them taking those steps and using their resources. So yeah, I think that's a really good thing. But to draw it back to the kind of the RCD angle with TT, because we've kind of dragged this episode on now for near enough an hour going off on one about MCS, but it's important, I think, as well to cover those kind of points, is if you're working on a TT system and you're supplying a solar PV or battery storage system, as long as you use a cable installation method that doesn't need additional protection, then you only need to use an RCD for fault protection. And that brings other options into play beyond 30 milliamps, where you can work with the manufacturer's instructions depending on brand. And I've got to say, most brands now, I think, are quite happy on 30 milliamps, my understanding. Whether they play ball with that 9 milliamps of maximum leakage that you want to see on a circuit or not, I don't know. But it's rare from what I've seen. I think the Sig and Star is one of the few that are still saying 100 milliamps, as far as I'm aware. For those of you watching, if you've got any other experience with that, drop it in the comments. But that's where I'm at with it, and hopefully those views, and it is chapter 41 of the regs for anyone who wants to go off and read it. There's the different earthing systems in there where it details all the different requirements. If you've got TN, TT, IT, you can dive into all of that in that chapter.
Yeah, no, and it's been a good one for me because I now know what I can do on this job. That pricing.
Thanks, Neil.
Yeah, thanks to everyone that's contributed to that. But it's an interesting one to look at in terms of the selectivity and lifting that, that main RCD. If you need that main RCD to potentially 300 milliamps, if you've got some distribution circuits, and so you're not just relying on that time delay, because I would definitely have been that guy that would have relied on that time delay between the 100 time delayed and the 100 non-time delayed. So yeah, that's another consideration to look at.
I think 99 times in 100 you get away with that, but the one time you don't, you'll wish you had upgraded it to 300.
And it's in Southampton, it's like 6 hours away.
Exactly.
So yeah, no, that's great. Well, thanks very much for your research on that, Mark. My contribution to this was I'll bring the regs book, and I forgot the regs book. So so yeah, no, thanks very much for clearing that up. But if you have any comments or questions about any of this topic, it's a very electrical kind of question. So anyone that's not an electrician might be kind of like, why? Well, let's just listen to these two guys speak about additional and fault protection. But if you've got any kind of scenarios that you've come across, any equipment that you've maybe fitted that was tripping a 30 milliamp RCD, it'd be interesting to hear what that piece of equipment was. What was the cause? Was it natural earth leakage? Was it induced by poor panels, poor installation techniques? And any other questions like this that you want us to have a chat about, because there'll be plenty more things that we don't know about, Mark, I'm sure, that we need to look at.
For sure. I mean, that's the beauty of podcasting, is you learn more than you give usually. It's massively helped me become a better electrician. So if you've got any topics for us, please do drop them in. Is there anything else you want to add, Sam, before I take us out on this one? I think it's my turn to take us out.
Yeah, it's your turn. Yeah, no, thanks very much for watching, everyone. Thank you.
Yeah, thank you all for watching, and as Sam has said, get involved in the comments. Wherever you're watching this or listening on audio, please don't forget to leave us a review. So if it's on Apple or Spotify, we're looking to try and build that up. Just a 5-star one would be nice, but if you're going to knock a star off here and there, we won't complain. Comments on the YouTube videos as well, and don't forget about Installer Show this June, 24th to 26th. We're going to be there. Take a day out at least and come along, because it's a great event to check out. And otherwise, we'll see you on the next one.
Thank you. Awesome.
That was a good one, I think.
Yeah.